Okay. So electromagnetic theory means here we are going to study the advance of your circuit theory. So what is circuit theory? A circuit theory will be consisting of two main components, active as well as passive. So active component means it supplies energy to do some work. We call it as active. So adula enna pathom, generally active component is called as source. Your source can be either it can be a current source or voltage source. அதுக்கப்புறம் என்ன பண்ணோம், passive components. So what are the passive components? Resistor, inductor, capacitor act as a passive components. So the work of your passive component is it accepts the energy and do its particular work. So if you give input, that is supply or energy to your resistor, what is the property of a resistor? It opposes the flow of current. It always resists the flow of current. So property of your inductor and capacitor, it stores your energy. It can be either in current or voltage. So if it is storing energy, then energy in the form of current, it is called as your inductor. If it is storing energy in form of voltage, we call it as capacitor. So your electric field, that is inductor, works under which field? Electric field or magnetic field? It works under magnetic field and your capacitor works under electric field. So இது பத்தி தான் பார்த்துருக்கோம், சரியா? So here in electromagnetic theory we are going to use the advance of your circuit theory. Instead of voltage, current அப்படின்னு சொல்லிட்டு பதில் here we are going to use electric field, magnetic field அப்படின்னு யூஸ் பண்ணுறோம். ஓகேவா? So source அந்த மாதிரிலாம் இல்லாமல் electric field, magnetic field. Then we are going to study about the charges. So இப்போ நம்ம என்ன பண்ணிருக்கோம், actually still now we will be giving a supply to a resistor or something, any components, it will be performing a work அப்படின்னு தான் நம்ம பார்த்துருக்கோம். So resonanceல என்ன கண்டிஷன் படிச்சிருக்கோம்? Resonance, when you have inductor and capacitor in a AC circuit, both should have a balance. Balancing condition la your power factor will be unity அப்படின்னு சொல்லிட்டு we will be making your resistor or capacitor to adjust the value equivalent to your unity power factor. That is your resonance. So in that resonance we studied about series and parallel resonance. Series la connect பண்ணா என்ன இருக்கும், parallel la connect பண்ணா என்ன இருக்கும் அப்படின்னு. So அதே மாதிரி இங்க என்ன பண்ண போறோம், we are going to include all your resonance concept, fundamental laws, fundamental theorems as well as your two-pole network in the form of three-dimensional view. Okay, so in the three-dimensional view அப்படினா என்ன அர்த்தம்? So in circuit theory, if you are plotting a graph for a Ohm's law, Ohm's law எப்படி பண்ணுவோம்? Ohm's law means R is directly proportional to, sorry, B is directly proportional to I into R, correct? B is directly proportional to I. To remove that proportionality, B is equal to IR and போட்டுக்கோமா. So B is directly proportional to I na, as long as you increase the value of current, your voltage starts increasing, correct? B வந்து directly proportional to I ன்னு போது I ஓட value 1 இருந்ததுனா voltage ஓட value 1, I ஓட value 2 இருந்ததுனா voltage value 2. So if you plot a graph, you will be getting a straight line. அப்ப அந்த graph பேர் என்ன? B directly proportional to current I. So I increases, B also increases. So it is 1, 1, 2 now 2. Like that it will be going. If you are plotting a graph, I as surface, B as your y-axis now, it will be getting a linear straight line. So if you are plotting a graph between x-axis and y-axis, it is called as dimension. X-axis now one direction, y-axis now one direction, two-dimensional views. In electromagnetic theory, we will be studying about three dimensions. X-axis, y-axis, we are going to incorporate one more axis. So we call it as z-axis. Can you draw any diagram in your three-axis? We cannot draw any diagram or characteristics, plot a graph for three-dimensional object, what I am going to do is I am going to apply a voltage source. So when I apply the voltage source, if this storing property is happening now, then it is called as electric field. Without applying any voltage source, if there is happenings now, it is called as magnetic field. அப்போ அங்கே என்ன தேவைப்படுது? We need a magnet. So when I introduce a magnet between the coil, there will be some force of attraction or repulsion. Then it is called as magnetic field. So electromagnetic field now we are going to combine these two properties. So I am going to use this magnet to energize the coil, and I am going to give a separate supply for the flow of current. It is called as electromagnetic field. So electric field na ஏதாவது ஒரு component எடுத்துக்கோங்க. In that component, if you are applying some voltage source, due to that some voltage source, there will be a flow of current or இல்லை ஏதோ ஒன்று நடக்குது. It is called as electric field. வெறும் magnet மட்டும் வச்சோம்னா என்ன ஆகும்? There will be a force of attraction or repulsion, then it is called as magnetic field. So in electromagnetic field, you are going to combine your electric field and magnetic field. அதுக்காக தான் பேர் என்ன சொல்லுவாங்க? Electromagnets. Electromagnets just we will be placing an inductor. In inductor, we will be when we insert a magnet, there will be some flux induced in it. So this flux வந்து நம்ம magnetic component கொண்டு வைக்க முடியாது. Instead of that, to produce the same effect, in this we will be connecting a external voltage source. So it is producing a electromagnetic field. Another magnets எல்லாமே electromagnets னு சொல்லுவாங்க. Usually magnet எப்படி represent பண்ணிப்பாங்க? Bar magnet represent பண்ணுவாங்க. You will be having north pole and south pole. So when you have a north and south pole, what will be produced here? You take a magnet. Around this magnet, if you are placing the iron fillings place பண்ணுவாங்க. சின்ன வயசுல பண்ணிட்டு தெரியுமா? ஸ்கூல்ஸ்ல பேப்பர் எடுத்துப்போம், மண்ணு போட்டுப்போம், கீழே மேக்னெட் வச்சு சுத்தினா அதில் இருக்கிற மண்ணில் இருக்கிற அயன் பார்ட்டிகல்ஸ் வந்து ஒரு டைரக்ஷனில் மூவ் ஆகும் தெரியுமா? அது இல்லைங்களா? ஸோ அந்த மாதிரி வச்சுக்கோங்க, இமேஜின் பண்ணிக்கோங்க. ஸோ இஃப் ஐ பிளேஸ் a north and south pole bar magnet, it will be consisting of two poles, north pole and south pole. Now I am placing the iron fillings. What is the direction of this magnet? Always there will be a force of attraction from north to south. North and south வரைக்கும் உங்களுக்கு ஒரு லைன் மாதிரி ஃபார்ம் ஆகும். So this line can be of any shape. ஓகேவா? ஸோ இந்த மாதிரி உங்களுக்கு போயிட்டே இருக்கும். So these lines are imaginary to your eyes, correct? When you place along with your stand only, you can able to see the iron particles. அது வந்து real time நம்ம எல்லா இடத்துலையும் கொண்டு போய் magnet வைக்க மாட்டோம். So same imaginary, that is this lines, imaginary lines will be formed around a magnet from north to south pole. So in electromagnet, instead of placing this permanent magnet, we are placing a coil and we are giving a supply, making it as an electromagnet. Here also there will be a flux generated around your magnet. So these lines are called as imaginary lines. This is called as flux. ஓகேவா? வெறும் ஃப்ளக்ஸ்னு சொல்லலாம், இல்லைன்னா மேக்னெட்டிக் ஃப்ளக்ஸ்னு சொல்லலாம், மேக்னெட்டிக் லைன்ஸ் ஆஃப் ஃபோர்ஸ்னு சொல்லுவாங்க. மேக்னெட்டிக் லைன்ஸ் ஆஃப் ஃபோர்ஸ். ஓகேவா? ஸோ இப்போ I am placing a magnet. Instead of that, if I am taking a charge, that charge particle will be, it can be in rest position or in movable position. Initially it is in rest position. So in this I am placing a positive charge, plus positive. So it is a positive charge. When I bring one more positive charge nearer to your first charge, whatever is here, there will be a force of repulsion. So there will be a movement in your charge B. Okay, in the rest position if I am placing one more charge particle with positive polarity nearer to A, then this A will be repelling your B charge. So it is moving in one particular direction. Okay, so this is called as force of repulsion. Instead of that, if I am placing a negative charge called as a two-dimensional view. For a three-dimensional view, what we need? We need three axes: x, y, z. So x-axis, y-axis, z-axis. So here, when you take this corner of your on the top, we will be having three dimensional axis, y-axis, union axis, y-axis, opposite axis, z-axis. Corner to corner, 3, 3, 3. So x-axis, y-axis, z-axis. So three axis components. So next we will be studying about what is your quantity, that is scalar quantity or vector quantity. Scalar components will be classified as scalar and vector. So scalar, if you are considering only the magnitude of any component, then it is called as scalar. Vector, magnitude and direction, we will be considering the direction. So here in electromagnetic theory, always we have to choose vector quantities. That means it should consist of both your magnitude plus direction. Magnitude plus direction. So scalar only magnitude, no directions. Vector magnitude plus directions. So when you go for this, it comes under vector algebra. So in vector algebra, what are the main components we will be studying? Addition, subtraction, multiplication, so when you take two components, A component and B component, if you are going for addition, then we have to add A plus B. For subtraction, A minus B. For multiplication, it is A dot B. So in multiplications, you will be considering either two values or three values. So two values na A dot B is enough. For three values, A dot B dot C. So here in multiplications alone, that is in vector multiplication, it will be classified into dot product and cross product. Dot product and cross product. So in dot product, if you are considering two parameters, A vector dot B vector into cos of angle between A and B vector. For cross product, formula will be A vector dot B vector into sine of angle between A and B vectors. So when you go for vector multiplications, you will be considering dot product as well as cross product. Dot product means A dot B cos theta, cross product means A dot B sin theta. Then here we will be choosing one more important parameter called as unit vector. Unit vector. It will be represented as A suffix n vector. Vector can be represented as cap or it can be represented by arrow. Directions indicate pannavalya. So it will be represented as arrow mark or cap. It will not go. So usually your unit vector is formula is, if you are taking A as a vector divided by modulus of example cricket ground. ஓகேவா, கிரவுண்டோட வாட்டர் லைன் இஸ் கால்ட் as a field. உள்ளுக்குள்ள என்ன இருக்கு, மெம்பர்ஸ் இருக்காங்க, ஒன்லி மெம்பர்ஸ் தான். ஃபீல்டு உள்ள பிளேயர்ஸ் இருக்காங்க, பிளேயர்ஸ் கிட்ட இருக்காங்க, அம்பையர்ஸ் இருக்காங்க, பேட் இருக்கு, பால் இருக்கு, ஸ்டம்ப் இருக்கு. ஸோ நிறைய நம்பர்ஸ் இருக்கு. பட் ஆனால் அது பர்டிகுலராக என்ன வேலை பார்க்குது, ஜஸ்ட் பிளேயிங் அந்த இதை தான் கன்சிடர் பண்ணுவோம். கிரிக்கெட்னா அது தான் கன்சிடர் பண்ணுவோம். அதே மாதிரி தான் ஃபீல்டுங்கிறது அவுட்டர் மோஸ்ட் லேயர் ஆஃப் யுவர் சரௌண்டிங். இப்போ இது எல்லாமே என்னது சரௌண்டிங்ஸ். இதில் இந்த லாஸ்ட் மட்டும் ஃபீல்டு. ஃபீல்டுக்குள்ளே யார் யார் இருக்காங்க கேட்டிங்கன்னா நாங்கள் இருக்கோம், டேபிள் பெஞ்ச் எல்லாமே இருக்கு. ஸோ அந்த மாதிரி சரியா. ஸோ ஃபீல்டுனா இட் இஸ் அ சரௌண்டிங். Inside that only you will be having your charges. So this charges can be either positive charge, negative charge, or negative. Positive charge called as proton, negative charge electron, and neutrons. So neutron is the immovable charges. So static portion. So that is called as static portion. Immovable portion அப்படியே ஒரே ரெஸ்ட் portionலே இருக்கு. சரியா. So you can call it as point charge. போட்டோல சொன்னேன்னா a charge at rest position we call it as point charge. Point charge னா ஒரே ஒரு charge. If it has only this charge it is called as a point charge. ஓகேவா. It can be either a rest position or movable position. When you consider movable position, what happens that we have to consider the speed in it. So when your speed is constant, we are going to analyze the magnetic field. So when the speed is different, then it is producing a wave. Wave will be generated called as electromagnetic waves. So in the மாதிரி வருது சொல்லுமா. So usually what will be your output for an electric field? Wave. Electric wave will be having a sinusoidal waveform, right? So this is your electric wave generated due to electric field. So here you will be having a constant time. At 0 it will be starting, at 1 cycle that is 2 pi it will be having a single waveform with positive charge or negative charge. When you go for a magnetic field, if you are not having a constant speed, what happens here? It will be having maximum magnitude wave. This wave is called as magnetic field. When you combine these two, it is called as electromagnetic field. So usually electric field will be having a equal amplitude and phase angle, whereas in a magnetic field you will not be having any, that is magnitude will not be equal, it will be deviating. You will be one for every. At starting you have the maximum amplitude, after that it starts reducing. Similarly in the ending la idhe nettam irukonu avasiyam illa. For an example solliya idhe மாதிரி இங்கே இருக்கலாம், maximum magnitude அப்போ ஒரு increase ஆயிடும், எப்படி வேணாலும் இருக்கும். So electromagnetic wave na it will not have any constant magnitude, it will be having a variable magnitude. We call it as electromagnetic wave. Similar, for the definition we can write, when you study the point charge at rest position, it is defined as study of point charge at rest position is defined as electric field is defined as electric field. Next point, study of call it as electric field. Second point, study of charges at moving position. At moving position. It is called as magnetic field. Third point, study of charges at moving position. At moving position with variable speed. With variable speed. We call it as electromagnetic field. Electromagnetic field. That means we are combining your combination of electric field and magnetic field for producing a electromagnetic field. So next take this difference between circuit theory and electromagnetic theory. Circuit theory and electromagnetic theory. So you may get this in 2-mark question. It is a 5-mark question or long answer question in unit 4. So what is the difference between electric and magnetic field? Difference between your circuit theory and magnetic theory, electromagnetic theory. So what is your first point? Here we will be dealing about deals with voltage and current. Here it will be in EMP, it will be deals with E for electric field, H for magnetic field. Next one. So when you apply a voltage to a coil, current starts flowing. First point overall. Consider when you apply a voltage source across a coil, current starts flowing. So what is produced here? Coil. When a voltage source is applied to a coil, current starts flowing. When current flows across the coil, it will be producing a flux. So here, flux is generated. It is represented by 5. This flux is called as electric flux. In EMP, same flux will be generated. It is called as magnetic flux. Magnetic flux or magnetic lines of force. wavelength, that is when we considering along with speed, denoted as lambda. Next, vector algebra topic ஆரம்பிச்சோமா. In that we had two parameters, scalar quantity, vector quantity. Scalar quantity na only the magnitude, not the direction. Vector quantity na along with magnitude, directions. So idhila nam enna padikuvom, directions. In the EMF all things will be analyzed under vector quantity nu sollana. So it means it is used for analyzing scalar parameters. Here it is used for vector parameters. Scalar parameter, vector parameter. Here, radiations will not be considered in your circuit theory. இப்போ நான் என்ன சொன்னேன், நம்ம போய் ரெஸ்ட்ரிக்டிவ் டைப் வச்சோன்னா ஹீட் ப்ரொடியூஸ் ஆகிருக்காங்கிறது நம்ம செக் பண்ணுறோம், இல்லைன்னா நம்ம அதை செக்கே பண்ணலை, ரைட்டா? ஸோ we are not considering about its radiation. Whereas in electromagnetic theory we have to consider the radiation. So அது இருக்கும். Radiation is not considered or not analyzed. Radiations are not analyzed, whereas here we have radiations are taken into account for analyzing purpose. Radiation is included. Usually, EMP na it is used for three-dimensional view nu solvaanga. Like next வந்து it can be used for free space analysis. Next one, சரியா? So here we will not be considering any free space. Vacuum அதெல்லாம் consider பண்ண மாட்டோம். Whereas here we will be considering the free space. சரியா? Same point. No radiations, no free spaces are considered in circuit theory, whereas here free space analysis are done. Free space analysis are